All right, good day, everyone. Today, what we're going to be talking about is going to be transformations, but we're going to be talking about it into a different light. Okay. So far, when the last time we did transformations, we had these types of problems shown on the screen currently. Okay. We were dealing with absolute values. We were talking about how these actual values shift a graph. Okay. Well, here's the thing. Each and every section technically has some sort of transformations, a way that we can graph it out by looking at the values given within a problem. Okay. Well, within this section, we're going to be talking about how do we take an x squared or something that is squared and how do we actually graph it out. Okay. We're already talking about how we get those parabola shaped figures, but we want to know how can we apply transformations or the things that we've already learned to help us graph it moving forward. Okay. So just a quick reminder, let's just kind of go through what these used to be, okay? Transformations really were listed out in 4 different types, okay? We either moved up, down, left, right. We had a stretch or a shrink, or last but not least, we reflected, which is just a negative, okay? So it's up to us to kind of remember what these were. Starting off, if we look at the first one here, we have a +1 on the inside and a -4 on the outside, okay? Any value that's being added or subtracted on the inside always causes it to go left or right, and it was opposite. So this one would have a left 1 movement, and then the 4 on the outside, because it's minus, would go down 4. So we would know that if we were going to graph this out, we would go left 1, down 4, and we would look something like this. Okay, because we'd go left 1 and down 4. Okay? And we could use those transformations to our advantage, okay? Then we had problems like we do in the second one, where we have a negative, which caused a reflection. And then on top of that, the -5 on the inside, pretty similar to the first one, would cause it to go right 5 units. So now, once again, if we're thinking about that graphically, not saying this is the exact right graph, but I'd go right 5, and then I would be flipped upside down to look something like that. Okay? So we were using these to help us graph this. Okay? Well, those transformations don't really change. Okay? Understand that what we're going to be seeing today is almost the same exact types of transformations. The only difference is how we're going to be referring to certain values. Okay? So, one of the key things that we're always going to look for is this idea of a vertex. This is going to be our key to finding anything. Okay? If I can find the vertex, then my problem is pretty much set in stone. Now, the vertex is just HK. Okay? Which I could almost simplify for you even farther, okay? If I was looking at an equation similar to this, H is on the inside and K is on the outside. Well, isn't that just like our vertex form? Where in this case, if I was looking at H, technically that's our left, right motion, and K is our up, down motion, okay? So the vertex can be found just by using our transformations. How much is it going left, right? How much is it going up, down? Okay. So we continue on. If I want to identify the vertex of the following, this one would be at -1 left, -4 down. Okay. So it's sitting right there. This one here would be right 1, up 2. Okay. So if you think about like how can I actually apply this, I can actually use this information to my advantage to help me graph out all this stuff. Okay. In yesterday's lesson, we kind of talked about this idea with these equations. If I know how it's going left or right, I can always find the vertex. The vertex for this one is going to be, well, how is it transformed? It went right 2, up 3. So my vertex is +2, +3. For this middle one, I don't go right and left at all because there's nothing inside parentheses, and I go up 4. So it's going to be 0, 4 for my vertex. Okay, so we talked about yesterday how we can find these values by using our particular transformations. If I know where it's going left, right, up, down, I should always be able to find my vertex. Okay? Well, in today's lesson, we're going to kind of go a little bit deeper into graphing these out. We want to be able to actually work out and actually understand, how do I graph these types of equations all the way through? Well, understand, whenever I'm graphing these out, after I get my vertex, it's fairly straightforward. Okay? So let's look at letter C here. We have x plus 3 and minus 5. So first and foremost, let's get our transformations. We have a minus 3 on the inside, which is going to cause it to go left 3. And we have a minus 5 on the outside, which is making go down 5. Well, little do we know that is actually our vertex. All right? So our vertex is just our left, right, up, down motion, which in this case, it's left 3, down 5. So if I went left 3, down 5, I could go ahead and plot a coordinate right there. And in all honesty, after I have that coordinate, I kind of can just graph it out. In this case, it goes up this way, and I have the picture of my graph. Okay? And that's kind of one of the key things I want you to understand. The vertex is going to help us graph all these out. Now, when we start getting stretch and shrinks, it starts changing a few things here and there. But at this particular point, we're kind of set there. Same thing with this one here, letter D. Negative 1 plus 2. This would go right 1, up 2. And at that point, we go right 1, up 2. And we have our graph right there. Okay? So let's kind of build off of that. All right? Because here's the thing. Technically, we have a particular equation, right? The equation in this section is going to be ax minus h squared plus k. Okay? And we know what these two are, but unfortunately, we haven't really figured out what a is. Well, that's kind of the thing that we really want to start discussing for today. A is what we call a stretch or shrink. And the easiest way we use this, especially for graphing, is we want to understand this as almost like a slope. So when we're graphing it, I want to assume this is kind of like a slope from the vertex. Okay? And so I want to use that value when we're graphing to actually understand, like, how is it actually moving? How is it actually changing my graph? So if we go to a particular problem, let's actually try to find one that we can use here. Okay? Oops. Oh, yep, that's what I wanted. Let's see if I can find a graphing one. Should be one popping up here. Perfect, right here. Let's say I wanted to graph this equation here. 2x minus 4 squared minus 3. Well, to graph this out, first and foremost, let's find our vertex. In this case, it goes right 4, down 3. So I have right 4 and down 3. We go ahead and plot that. Right 4, down 3. It's kind of right in the middle between those. And that is, once again, our vertex. Well, now we have to kind of change one small thing because we have this 2 here. That's going to cause a stretch of 2. And the thing that's important here is that what that does is it's really going to be our counting points for our slope, but from the vertex. Okay? And that's the key thing I want you to understand. It's the slope from the vertex. So if that's my coordinate, I want to count up 2 from that and plot a point on each side and then graph it out. And what it does is it kind of narrows your graph. Okay? Because that stretch is there, instead of just drawing the graph, I have to have particular coordinates for each one. Same thing will be applied here. If I quickly look at this and say, my vertex is left 3, up 2. So we have a left 3 and up 2. That's our vertex. Well, then when I look at this, when I graph this out, left 3, up 2, the second thing I have to look at is this value right here. And in this particular one, there's a little bit of a curveball because there's two different things we have to understand. First off, it's a stretch of 4. But on top of that, it's also a reflection. Because it has a negative, we know instead of pointing upwards, it's going to be flipped and pointing down. So if I'm going to start at that vertex point, I'm going to count down 4 units, 1, 2, 3, 4, and plot a point on each side of the graph. At that point, I can connect the dots and I get my picture. Okay. And that's kind of one of the main ways we're going to graph this out. Notice how it starts with me finding the vertex and then finishes with me actually plotting the stretch or shrink and reflection on top of that. Okay. But besides that, that's kind of the main idea of today's lesson, being able to develop this stuff and then build off of it. Okay. We'll go more in depth tomorrow. Besides that, have a great day.